Another rules for depth of boring for hospitals and office buildings. For hospitals and office buildings, depth of boring is equal to 3 S 0.7 for narrow concrete building. Then where dB is depth of boring in meter, S is equal to number of stories the exploration cost (0.1 to 0.5% of total cost. Approximate spacing for boring multi-story building, then one-story industrial plant, then highways, then residential, then dams. Multi-story is 10 to 30 meter, one-story industrial plant is your 20 to 60 meter, then highways 250 to 700 meter, residential building 250 to 500 meter, dams 40 to 80 meter. Also sometimes we use this thumb rule. Vertical stress due to proposed structure which is equal to less than equal to 10% of effective stress. Then it may be so one boring carried to bedrock or at least level below the anticipated level of influence of the building where may be bedrock coming into picture. Then for light story structures, for light structures, boring should be extended 4 times footing width. Not less than 6 meter below footing. Or heavily loaded structure 50% boring should be extended 15 meter below footing or foundation. Now, if you look at this, there are 2 parameters. One is your depth of boring, another is your number of boreholes you are supposed to carry out. And if you look at this depth of boring, last class we consider based on the stresses acted on that, but there are certain thumb rules also applied, guidelines also given. For hospital and office buildings, this depth of boring is 3 times of S. For narrow concrete and for heavy and wide concrete building, S is your number of stories. S is your number of stories. So, 3 times number of stories to the power 0.67, 6 times number of stories to the power 0.7. So, one thing is exploration cost, whatever you are going to do the subsurface exploration cost is always you have to maintain 0.1 to 0.5% of total cost. Now, this is just approximate spacing of the boring, some guidelines are there. Now, for multi-story building, generally it is preferred between 10 to 30 meter, the spacing of the boring between 10 to 30 meter for multi-story building. 1 story industrial plant 20 to 60 meter. For highways as it is continuing, it is 250 to 700 meter, and residential building 250 to 500 meter, and dams 40 to 80 meter. Now, instead of going this maybe you can use this thumb rule. What thumb rule says? Vertical structure increasing vertical stress due to proposed structure, that means increase in stress due to proposed structure, where it should be less than 10% of effective stress. That means increase in stress or vertical stress due to proposed structure, it should be less than below the footing, somewhere else less than equal to 10% of effective stress. So, that is your depth of boring. Then if below the foundation, if bedrock is nearby, try to go for a borehole. At least one boring should be carried out up to the bedrock if bedrock is available. Then for residential buildings, boring should be done at least 4 times width of the footing. If you look at here, generally the pressure bulb is 2 times B2 4B. This is my width of the footing. So, for residential building or light structures, boring should be done, that means depth of boring should be 4 times width footing, that means this is 4b plus this depth. This is your depth of foundation. So, 4 times width of the footing plus depth of foundation, this total will be, this is your depth of boring, or it should not be less than 6 meter below the footing. For heavily loaded structures, that means multi-story buildings, 50% of boring, 50% of boring, suppose this is an area, 50% of boring extended below 15 meter below the footing, at least 50% of boring, suppose it is decided number of bore holes to be carried out in multi-story buildings, say 5 number of bore holes. With this 5 number of bore holes, at least 2 bore holes should be extended up to a depth of 15 meter below the footing. These are all these thumb rules. So, maybe certain guidelines are there. So, practicing engineers, they decide from case to case what criteria they are going to use, and also depth and spacing of the boring, means particularly depth is more important parameter, means what depth you are going to carry out your boring and collect the undisturbed soil sample, and spacing depending upon that, the spacing also it decides how much your spacing going to take between the each boring, what is that spacing you are going to take it. Now, we can discuss one more thing. Suppose this is a proposed site, this is a proposed site, it has been planned to go for multi-story building, and nearby you see nearby there is a pond, and nearby there is also a road. Now, how do you decide how many number of boreholes you are going to carry out? If you look at this is a proposed site, the proposed site is very close to pond, because once there is a pond, this water table may rise or water table may fall depending upon the weather. So, this has a effect of a water table to the proposed site. So, nearby this pond, first is nearby the pond go for a 1 borehole, I am talking about number of boreholes. Then if there is a road or maybe a rail track, so because of the road or traffic load, because of this there is a kind of cyclic load may come into picture. So, maybe one more boring you can go nearby the road, so that you can get how much the soil, how much the disturb means soil profile it is coming. Now, if this is the proposed site, after this 2 bore you can decide, because bottom line is your the cost of your subsoil exploration should be 0.1 to 0.5% of total cost. Now, you can decide 1, 2, 3, 4, 5 at the center, or you can decide 1 at the corner, 1 at the center. It depends upon the how this proposed structure means, what is this structure, is it a light structure, it is a multi-story building, or it is for industry purpose. Depending upon the use, the number of boreholes has to be decided, but depth you can go for from this thumb rule or based on the stress criteria, or maybe based on the residential building, or maybe other criteria practicing engineer used. So, these are the 2 major parameter before you start planning your subsoil exploration. One is your depth of boring, and second is your number of boring. Now let us start with this boring. Now this is about planning depth and a number of bores. Now boring. What are the different boring? One is you can do it by means of a trial pit. Second is your was boring. Third is your auger boring. There are three kinds of boring. One is your trial pit, second is your was boring, third is your auger boring. Now let us start with your trial pit. Now come back to trial pit. First criteria is this trial pit where you are going to use. If it is required for subsoil exploration up to a shallow depth means subsoil exploration say up to 2 to 5 meter depth, then or maybe up to maximum say 7-8 meter depth. So then you can go for trial pit. What does it mean by trial pit? A pit approximately 1 meter by 1 meter by 1 meter. It is not necessarily that it should be 1 meter by 1 meter by 1 meter. What I said, approximately 1 meter by 1 meter by 1 meter, you do this pit. Then once the pit has done, so you go inside. First you look at how the soil stratification within that 1 meter, is it varying the soil stratification? If it is varying, what is that indication? Suppose this one is very dry, you can look at by visual inspection, it is very dry. Even if you take a soil from this stratification in your hand and pinch and you can rub it, you can find it out whether it is a coarse grain or fine grain. You take the soil and rub with your forefinger and middle finger, then you can find it out whether it is fine grain or coarse grain. If it is a coarse grain, you can clearly observe there are particles, and is there any moist? Questions during stratification. First is how the soil layers, how the layers are they same or different? If different, how it looks? Is it, if different, is it dry or wet or moist? So this gives an idea whether there is a soil stratification varying at shallow depth, or maybe the soil profile up to the shallow depth will be same. Once this stratification you can observe by visual identification, then you can take this casing pipe here and push it, not by hammer, you push it inside, so that slowly you push it inside. So, this casing pipe will go inside. So, once it go inside, you take out by means of chisels this casing pipe, make it out. Once you make it out, the casing pipe it collects undisturbed sample. By means of wax, both the ends by means of wax, you make it watertight. This is your wax. Watertight, so that moisture content preserved, then this undisturbed soil sample can be taken to the lab for soil testing. This about this sampling tube samples, this we will discuss after this part of the boring. Then come back to next is your wash boring. Now, in this wash boring, boreholes made generally 150 to 200 mm dia, suitable cutter. This is a suitable cutter. Dia with a suitable cutter at the bottom of drilling rod. Boreholes made through a suitable cutter at a bottom, at the bottom of drill rod. Soil is loosened and removed from the borehole by water. Soil loosened and removed from borehole by water. or water mod water plus mud, it carries soil up to the annular space through wash pipe. Just after this, once boring is over, we will discuss this is what kind of soil it is required, this is what kind of soil, and Auger boring if soil profile is there, because these are the techniques. What boring means, trial pit where you are going to apply, wash boring where, and Auger boring. Now come back to wash boring. In this method, what this is a diagram. In this method, generally bore hole of 150 to 200 mm dia has been done. How you made it? Generally a cutter, particularly a cutter, once there is a drill rod is like this, at the end there is a cutter, at the end is there. Once the drill rod rotate, this cutter will move, so it will cut from the ground surface. So with this help what will happen, soil will loosen and this borehole has been made. Now by means of water injected inside, this soil, loosened soil will mix up with this water and it will become mud, means mixture of soil and water. It will come out through the wash pipe and outside it will come out, and nearby some tank has been prepared where this soil plus water has been settled, means soil has been kept inside a settling tank where this soil settle, then water comes out. Over the period of time soil settle. So once soil settle, then you can insert the pipe mold inside, then you can collect your undisturbed sample. This kind of soil, particularly wash boring, particularly this kind of technique, wash boring technique, indirectly it is giving remolded soil sample, because once you are going to do boring here and collected soil in loose condition with water and taking out here and make the soil plus water settle in a settling tank. So this is remolded, disturbed sample, put it there, once it settle, then you collect your undisturbed sample. What kind of soil this wash boring generally adopted, that you think, because these are the all techniques. I am going to discuss also what kind of soils this wash boring to be applied, and for trial pit I have already said this is suitable for shallow depth. Now come back to auger boring. Manually or mechanically operated. undisturbed samples obtained pushing sampling tube. Now, if you look at this auger boring, generally this may be manually or mechanically done. This is a drill rod shaft, it is connected by means of auger. This auger, particularly this auger, is this kind of shape with there is slightly cutting edge, this cutting edge at the end. So, once it go inside by means of drill rod, this is your handle and this is your drill rod. You can do it manually or mechanically. Once this drill rod manually or mechanically you rotate it, what will happen? It will start cut the soil where it is lying, means it will start from the surface, cut the soil. Once it cut the soil goes inside. So, once it full, no more cutting is there, you can take out and remove the soil from the auger. Then again you advance, that means layer by layer you drill the borehole, and go. Then once this borehole has been made, suppose it has been set, you collect undisturbed sample at 6 meter depth. That means first you do the boring by means of auger boring. Once boring has been made, DPTH, once boring has been made, this auger has been detached from the drill shaft, then sampling tube has been connected, sampling tube connected with this drill shaft, so that it can be pushed inside the soil below the 6 meter. So, you will collect undisturbed sample. Once you will collect this undisturbed sample, take out from the ground surface, then after collecting undisturbed sample, once you collect the undisturbed sample, put wax or wax outside, cover it, so that it become, you make it watertight. Once it is watertight, this natural moisture content has been preserved and it can be taken to lab for laboratory testings. Now, this is first part we have finished planning. First part we have finished your planning, that means boring, number of boring, number of boreholes and depth of boreholes, planning is over. Then technique, how do you decide by how do you do the boring? Either you do it by trial pit or wash boring or auger boring. Third one is your rotary boring. This I will show, not third one, this is your fourth one. This I will show some photographs, so it will clear the completely, it will clear the visualization how this rotary boring has been done or conducted. Generally in India people do it by means of auger boring, because manpower is cheap and this can be done manually also. If you look nearby somewhere else, manually while constructing house, people do it by means of handle, this auger pushed, so it cut it. This kind of auger they use, or sometimes they use also blades, cross blades, so it will rotate so that soil can be taken out, or maybe sometimes spiral blades used so that soil can be taken out. So, this particularly auger boring is most popular in India. So, these are the 4 types of boring. One is your type trial pit, then second is your wash boring, third is your auger boring, fourth is your rotary boring. Now, what are the field tests remaining, what are the means not remaining, what are the field tests supposed to be carried out. First part is your planning, that means depth and number of boreholes. Second part is your boring by means of what are the different boring methodology, trial pit, wash boring, auger boring and rotary boring. Now once the boring is over, that means soil sample has been collected, undisturbed soil sample for laboratory test. Then what are the field tests it is required to do and what purpose. First one is your relative density. So this granular soil it is SPT, standard penetration test, or dynamic cone test. Second one is your shear strength, cohesive soil, in this case three field tests, bend shear test, direct shear test, then static cone test, then bearing capacity, and settlement. In this case plate load test, permeability, borehole or piezometer test. Then compaction control, here it is moisture density or severe test.